Welcome to CANopen Automation webinar with the topic CANopen Lift. My name is Oskar Kaplun. I will lead you through this 1 hour. We will have about 2 parts in general. I will briefly speak about CANopen Automation itself. What is this as an organization? How it is connected to CANopen Lift. And then we'll talk about CANopen Lift itself. What is this? If you are not known this by now, and what can it do for you, or how can it be of the use for you as developer or system integrator for elevator components and systems if you design it. Briefly about myself, I'm working about 10 to 12 years already by CAN Automation. Started as engineer, and I'm working here for some testing for CAN-based devices. I do also supervise multiple technical committees at CAN Automation, and we basically design specification and test CANopen devices. CAN Automation was founded at the time since 10 years past of developing of CAN bus. Industrial automation, people found out that CAN could be very useful also for not only automotive, but a wide range of industrial application. So the know-how wasn't there or was only partially at automotive. So it was the idea to create some kind of international manufacturer organization that can be providing such a know-how information and also support CAN-based technologies and move it to the market. So the organization is located in only one place. This is in Nuremberg in Germany. We have contact data. We have also a website where you can find all the further information on that. Then I'll briefly give some history lesson when it all started and where we are now. It started, as I said, 10 years after development of the CAN bus in 1992. It's official founding of the association. The first things were to provide information about what is this all about and how the people who would like to start developing with CAN bus came to the knowledge how to do so. Organized some joint booths for CAN-based technology. And that time, CAN as itself is just data link layer. The application could be manufacturer specific as it is in automotive. Or in case of industrial application, much more comfortable if you have compatible, open, license-free protocol that every industrial application can use in their systems. So the CANopen specification was born 1993. After the series of specification was released from CAN Automation, and finally it came to the CiA 301. This is naming for CANopen application layer and communication profile, which is basic specification. All the other CANopen specification for every devices or applications where CANopen interface is involved, CAN-based CANopen interface is involved, is derived from this specification. The next steps were, of course, to provide opportunity and possibility to test these devices, such as CANopen test tool. Then we pushed into the market, organized some conferences, created further specification. As you can see, I have marked with the green color CANopen Lift specification from the start to the current development stage. Now is the version 2.2 available, but it is based from the version 2.00 there is not much dramatically changed in there. We maintain specification and extend it with just new functionalities in there, but the basic structure remains the same. It's not to mention that we have also a various range of specifications. Specifications and technology emerged in the past 5 years, starting with new CAN technologies, is CANFT and CANXL. There is new technology being standardized. They increase payload of the CAN bus, but for the moment, CANopen Lift is designed only with classic CAN. So CAN Automation is membership-based organization over the course of the years, as you can see from the graphic here, from this diagram. It starts with very few members and grown up to more than 750 in this year. This just says that the interest to CAN-based technology is not necessarily all covered for CANopen Lift, but the general CAN-based technologies is still in large, and our organization continue to flourish, and our members got all the information they required and are still interested in being inside. So CAN Automation, of course, is providing not only product but also marketing related information. For this case, we have 2 arms, so-called, of the organization. One is the marketing arm, another is financial, and another is a technical arm, which handles specification. We have marketing groups in a marketing arm, which handles visits to the exhibitions, representing our members, and exhibition representing technologies developed within CAN Automation, organizing technology days, such webinars like this one, also CANopen seminars as well, and other events. We have joint booths, and of course, since the topic is CANopen Lift, we also attending multiple elevator exhibitions around the world. Especially, we will visit Interlift of this year next week in Augsburg, but about that later. The other arm of CAN Automation is technical arm. What does it mean technically? Basically, we design specification and provide together with our members and release this specification in various forms that could be then implemented in various devices supporting CAN-based interfaces. As you can see, it's actually the big one has structured in multiple subgroups, so-called interest groups. This all is because of multiple CAN-based technology. We have 3 as of right now. So we have split it separately into CAN-based technology, into protocol level, and also into application level. Application level will be, in this case, you see CANopen, CANopen FT. This is application level protocols. On the far left side is the lower layers. This means actually this is data link layer and physical layer. We handle all 3 technologies within these working groups. CANopen Lift is a working group assigned to the profiles. So we did this independently because now we have 2 application layer technologies, and we said that the profile parameters and features remain the same. It's just communication technology protocols can be different and extended, so we have to assign them in a certain way. So CANopen Lift is located in your profiles. If you would like to work with us, you're interested in bringing your requirements into CANopen Lift, then you're welcome to contact us and ask for participation in CANopen Lift meetings and development of CANopen Lift specification. So far about technical marketing groups. Now I'll briefly describe what service we actually offer in this case, what is in it for you, for example. Either you're system designer or device designer, tester, technical or marketing personnel. Everything is covered. You have and receive information from us and can participate in our marketing activities, technical activities to promote your product and develop your specification, and develop your lift system, for example, among many others, and get some updates, test the devices, test the system, something. So many things are possible. They are services, some of them are paid services, some of them are open services. So this is not limited with CANopen Lift only, but it's just an idea to give you thoughts. What are the services we offer? How can they be useful for you? So, among other things, if you design especially CANopen Lift system, you would need to check if this works in the field. So either the components are compatible with other components, with the whole lift application, either they fit into the host controller, can operate, receive the data, submit it back, and so on. This is one covered by interoperability testing. Basically, for every CANopen device is possible. For Lift, we do have CANopen Lift Plugfest. We celebrated this year already 20th year of the existing of the Lift group, existing of the specification, first specification, and at the same time, it is actually nearly 21st CANopen Lift Plugfest we held this year. So, and finally, come back to the Interlift next week. We will be at the booth 311 in Hall 3. If you be at Interlift exhibition, you can visit us, get the latest information on development of specification, further development on CANopen, CAN technologies, whatever you seek there. You can get free copies of our editions, publication, CAN newsletter in hard copy, can discuss with our marketing and technical department. Me, be also at this exhibition, starting from Wednesday till the Friday. I'm also doing a presentation on latest development regarding cybersecurity in for CAN-based technologies, specifically considered for CANopen Lift networks. You're welcome if you're registered and VFA forum in Hall 2. It will be held on Wednesday after lunch. You can look out for that presentation in the program of the VFA forum. You have an opportunity to get a free Lift poster. It includes process data and application parameters. In general, you needed to know about if you design CANopen Lift application, CANopen Lift component in the system. Since we promoted since the start, we have now about 50 companies developing Lift. We said in a group, in a working group, we'll come to this later, for CANopen Lift within CANautomation, at the very beginning, that the specification you would develop would be available for members with the recent changes, updates, and so on. But in order to bring some people, new companies inside to make widely acceptable lifts with CANopen interface, we said we'll provide also, sorry, a public available versions, which will be available to all. These versions will be, of course, the older one. But since we said we would like to keep the backwards compatibility, I would say membership is not required there. You can just look into this, start development, and so on, can get the first glimpses how this CANopen Lift specification works, how you design devices, how does it look like. For more advanced approach, if you design professionally and would like to push into the lift markets, membership has certain benefits for you. Then you get the very recent development of CANautomation specification for CANopen Lift. So be up to date with the very latest devices and improvement in there, and the fixing we did to maintain this version. I will leave you to read the benefits. As I said, we put this video also on YouTube, and I submit to all the participants of this webinar, provided you registered for this webinar and can verify yourself. We provide also the slides of today to you by email, where you can read, of course, this into details. There are also publications. Some of them we are offering on a Lift exhibition next week. Most of them you can order from CANautomation or read on our website. We do also advertisement in this media, diverse media. So if you would like to post and do some marketing activities on that, advertise your product, you're welcome to contact us on this regards. The next few slides before we start really with the topic of CANopen Lift, what is this all about, I would like to draw your attention to our other webinars in this year that are still remaining, this future of CANopen technologies. I will plan also webinars for the next year. I do not know when we do have a next CANopen Lift, so use the opportunity to read it in details right now. There is also a different approach, a day or half of the day of the presentations regarding specific technology, specific topic in CAN-based design, which we do in CANautomation technology days. There are still some available this year. They have the various topic. You're welcome to check this out and see the nice presentations in these topics. They might be interest for you. We do not have specifically CANopen Lift topics. We had it last year. You're welcome to check in our YouTube channel, this one from the last time, from the last year. The least but not last is the International CAN Conference. We organize biannually. We have already many of these conferences. The topics vary of presentations and product demonstrations vary from all three CAN technologies and various other topics. If you would like to participate, we have a program. We will have soon the program of the conference. It will take place in Baden-Baden next year. on 14th to 15th of May. You can find the whole information on our website. You may register yourself. If you find the topics of presentation interesting, and you would like to get to learn it. The proceedings, the slides, all the slides from the past conferences are available for free download from our website. So, and this is a slide with more details on this international conference in Baden-Baden. You will be able to participate. You can register for that at our website. Publications, again, just point you out, there are various things in there possible. You may put your advertisement in CAN newsletter online. You can also do the product-related advertisement, post it and ask us to do this in product guides. And we have some email subscription for information to members and non-members, what is going on in CAN automation community, what does it happen with certain technologies, and so on. Last and not thing is you can read all and multiple information, multiple things on our website, some knowledge base, some previous details on, or some short details on various specifications we release, and get all the updates also in social media, like over the Twitter, LinkedIn, YouTube, and the other things. The participation in various exhibitions is triggered basically by our marketing groups, which say in certain markets we have to be present to inform our members and prospective members and all interested parties who attend this exhibition, where we are taking place, what is going on, and such further things. So the first part is done. Now we go to details on technical side. What is CANopen Lift? If you don't know this now, that's will be the good time to hear this in there. So CANopen Lift, it is a trademark for CANopen Lift, CAN-based CANopen interface and CANopen devices with CANopen interface used in elevators and lifts, especially lifts for host controls and for whole lift systems that communicate the data over the CANopen interface. On the other hand, beside the trademark, is also CANopen Lift is a working group. The exact name is Special Interested Group CANopen Lift Control. This is the name you ask about if you would like to participate and know a little bit more about the activity of this group. If this 1 hour webinar will be not sufficient as an information for you in this case. It started 20 years ago with a purpose to design specification for lift components and lift host controller to maintain the whole communication in a lift environment, in a whole lift, having the very same way to communicate process data. And it covers system integrators and device designers in itself, marketing personnel, whomever it may attend who works in a lift branch. We have about 50 companies. Their number grows constantly, although not very dramatically, because people already know this. And some bigger companies join us also in meanwhile, because they see the advantages of CANopen interface for them. As I said, already 20 years passed. Over these 20 years, we've collected knowledge how to do things with CANopen Lift, how to do lift things based in CANopen interface, what are the problems, how can we solve this, how can we succeed in design of lift systems using CAN-based technology. Straight to the point, specifications are available at CAN Automation, the very recent versions available for members, older versions available public to get a glimpse how to do the things. The specification calls 417. DSP stays for draft specification proposal. This specification can be used for design of components and a whole lift network. There are different stages of this. We hope to release the next version very soon. It has 4 parts: designing basic concepts, then present process data, and finally defines the application parameter necessary to exchange the data between the components. Some add-ons, such as bootloader and power supply and further things, provided in specification 814. This is implementation, so-called implementation user guideline, how to handle those things. I assume there will be further parts for that, as well as constantly we add new functionality with our members. We meet actually for now annually with this working group CANopen Lift Control, discuss recent changes, discuss changes in specification, and assign plans for next activities, and maintain specification and discuss about possible release of certain parts. Now we go straight, what is CANopen Lift? What is CiA 417 application profile? Why it is called application profile? If you don't know, now we have device profile, a generic profile, application profile. Application profile is meant to describe application design specification for the whole system, where all the components described inside with their parameters also designed in a way that they communicate in one system and interact, and pre-configured for this interaction within this system. This is why it is called application profiles. There are also device profiles, where we have single devices which are not affiliated with any application. They could be used in any application. So for certain reasons, most of the components of Lift emerged from CiA device profiles, but they have to be adapted for the Lift application, so they are not backward compatible with a device part counterpart. So to design this one, you need 417 application profile for design of your system or design of your each single Lift components. Application profile includes following parameters. You can see them now. Most of those parameters are communication parameters. Some of those are application parameters. Communication parameter define how the communication is done, which protocols I do use, and application is what parameters I use for interact my certain process data. For example, what is a controller, what is a card drive position. This is application parameters. Why do I need these things, and what are the constraints of my Lift application? So we design this the way, using this specification, you can design up to 8 Lift applications, independent Lift applications, and each can be having to control up to 254 floors. This is a maximum possible scenario. There could be also things that could do to extend this range, but not simply, and would require certain tweaking in this case. Basically, this is the maximum possible design. More practical is a little bit more limited. There are 1 or 2 lift applications, maybe even only 1 lift application. We have about 20 to 30 floors, depending on the size of the story of the building where the lift is used. And then we have this as application profile, and we have here just typical block diagram of the single shaft, single application, maybe, to make this simple, with components that interact over this green marked CANopen network. You see this, we introduced here physical and virtual device. We'll talk in the next slide about what is difference between physical and virtual device, what they are here for. As you can see, with some virtual devices can be inside of the physical device. This is simple explanation. Virtual devices are more or less software pieces which reside in a physical device and allow interaction between internal components, even if it is considered a CAN bus outside. It could be also a distributed part of physical devices, but the virtual devices are always inside of one physical device. There could be several physical devices on a bus, as you can see, but there cannot be one virtual device shared between physical device. There may be some cases where you need to interact within one and the same device, or maybe different devices, communicate between the very same type of virtual device. This means you have to implement in both devices, both physical devices, this virtual device. Not share it between these two, but implement it twice, once in one physical device, another in another physical device. They have to interact. This allows to create actually some kind of gateways and can increase your network into kind of proxy that you could push all your data between multiple networks you may have also inside. But for now, we'll concentrate on a simple solution. We have physical and virtual devices. Physical and virtual devices, as I said, one to many virtual devices, several virtual devices can reside in one physical device that provides some opportunity, like you see in the picture. In the middle, there is car door. You could call it light barrier unit, car door unit. They are virtual devices. They are both reside as a piece of software in a car door controller. And this means that this information comes inside or comes outside is necessary for operation of the car door itself. Now, this producing and consuming is, I would point you out to the basic principle of CAN communication. One device produces the data, all the others consume. There's only one producer on a bus. That allows to create a distributed network of multiple devices, which each of them could submit and receive the data and can submit the data in broadcast to multiple other devices. It has their advantages, and its advantages fully used in CANopen Lift. So now the question is, of course, how do I know what is my piece of software inside of my physical device? What other physical device could it be? So we structured this into the values provided in one of the parameters in this specification 417. You can distinguish between several virtual devices or only one, and you exactly know where it is. From the object 1000, this object is mandatory in each CANopen component or the host controller. Each CANopen Lift device has to implement this object. By this means, if you have some tool, you can read from each object which virtual device or devices does it support. The object 6000 provides further information in case the device supports multiple virtual devices. To structure it much more, as I said at the beginning, as we saw this block diagram of the building where the lift application, many lift applications inside, there is designed, the specification is designed that application parameters are called indexes. The total number of available indexes are structured in 8 ranges of indexes, meaning that could be independently controlled 8 lift application. Every single lift application is also structured by its virtual device kind, so I can design many virtual devices within one application and within each single physical device inside. The key component is, of course, process data, exchange necessary information, position value, where's my lift cabin, how do I get the signal from the car outside, when the door should open and shall open and so on, is called process data object in CANopen. This information is sent in broadcast, and each single application has structured their number of virtual devices, and to each virtual device, a number of such PDO is assigned. So, you know, if you design a specific device with specific functionality, there are only certain number of PDOs, specific PDOs with their numbers assigned to this device. Here you see only one table for one virtual device for car controller, and it is served to simplify your understanding how the things work in there. For example, you see this number of messages, they have CAN IDs, they have TPDO and RPDO. TPDO means this process data configured in one device, and this device will be transmitting this data over the CAN bus to all the others. And the receive PDO means that those devices receive this data from the transmitter. To make it a little bit simpler, check this out. Car position unit will take us with a message number 1. As you can see from the first table, the second table gives you information what exactly is the data is transmitting. So we're talking about car position unit from left to right, message number 1, TPDO number 263. It has one CAN ID, and of course, to make this communicating between 2 different participants, they have both to have these PDOs with the very same CAN ID 180C hexadecimal. So this means in one device, this is TPDO, in another device is RPDO, and it depends on if this device receives this PDO or transmits. So this called PDO linking, sending one device with one and the very same CAN ID, the data is transmitted and received exactly, sorry, wrong slide, exactly in a place where it meant to be. So we go with the first one, just make an example. Position unit, this is actually position value from unit 1. So car position unit submits this value in a TPDO 263, and it goes to car drive unit, as you see from the first table above, and to the car drive controller. More interesting example is the message number 2. This is car door unit, does also sends the data, but in this case, not the car position unit receives anything, but the car door controller needs this information. What is this information? This is actually current status of the door and position value recently at the door to know for car door controller if the door can be opened or not. Just to make you understand, these PDOs are designed for only one of many virtual devices and are strictly tailored exactly for this device. So there's 6 PDOs will be transmitted by this virtual device. And in some cases, the data is transmitted. In other cases, this data will be received on a bus. So this continuous exchange of the data occurred by this means. This was an example. So you know about parameters, generic parameters, application parameters. Now with PDO, we learned both of them. You learned that if you didn't know this up until now, what is this all about? Then PDO is the key component. This is protocol that is used to exchange process data between Lift components in CANopen Lift network. Now we talk about a couple of add-ons for Lift network beyond the standardized application, beyond the typical application you use. In the recent years, strong interest grown for Lift condition monitoring. So we designed actually for this case already parameters on a recent specification. The component can exchange necessary data. They are limited to 40 to 50 pieces of data fit into PDO. Do not disturb, this information doesn't disturb dramatically CANopen network, and delivers information that every component can reuse and can submit about its current state to provide further details to the people or systems monitoring the condition of the lift and knows when to replace or trigger the maintenance. This is actually quite advanced stage we designed for that case. If you have questions, I would like to point you to the newest specification. Ask me about this one. The data flowing through the CAN bus, in this case in CANopen network. There are 2 networks in a simple single shaft application. There is a green marked areas. They are physical devices which get hold of this condition monitoring data received over the CAN bus from this component. As you can see, there's special condition monitoring unit which specifically tailored, designed for submitting this manufacturer specific then into cloud services or maybe to the technician in the field. There is also possibility on the left side for having TCP IP gateway, which also connected into this way into the cloud services over the long TCP IP network infrastructure, including edge gateways, some other key components necessary for this. And finally, the data which is collected straight from the Lift network is host controller itself. This is a green piece in the middle of the network. It has connected both networks in there, and basically it gets all this data inside and could be used also to collect this condition monitoring data. Another thing as add-on, we saw every component can be updated, that the clean device is not even CANopen, can be designed as being CANopen. So you have blank devices with certain capabilities. You have to install the firmware on that to make this device capable of this. It could be also reasonable. You may have some several buttons and or audio-visual indicators that are having these capabilities but not CANopen yet. So you could update them into this, making them CANopen in itself. Therefore, this reason bootloader can be used as well, or update the firmware inside. Bootloader for 17 specifications, so CANopen Lift bootloader specifically, is more or less derived from the very generic bootloader, CANopen bootloader. Has very generic capabilities, very few specific things. So far, it is generally accepted by the group and designed knows this one, but they may lack certain capabilities, which I would point you out, are provided in our another initiative. We design now generic, redundant modular networks and bootloader for generic usage in all CANopen application, not only Lift. This one should be designed in a way that fit into most applications. Maybe one day we'll see this also in a Lift. But I would like to step aside to a side and show briefly with 2 slides what are these recent activities. Redundant network can be used also in Lift. If this case of capabilities, if somehow the Lift network requires this one, we have designed this by now, but it was only used for maritime application for only limited time. For the moment, we redesign this in a basic generic concept for all possible applications. This means for those of you who know what we're talking about, this is dual redundant CAN network, including 2 physical and data link layer, means 2 transceivers and 2 CAN controllers, but they are joined in one application layer, meaning there could be also a CANopen device. Each CANopen device in every network, each component can be connected to the host controller, Lift host controller, with straight and redundant line. More on this, you're welcome to contact CAN Automation to learn these things, how they work. Here's a small example. What is an active and redundant line? How do they used in this case? So finally, we have also a power supply recently designed for Lift applications where needed some uninterruptible power supply in there. in some heavy or difficult areas, specific areas, and maybe at the places where the too much sun, or let's say sun is shining almost the whole year, where the solar cells can be used to additionally provide us supply for the lift application. So we have this add-on as well. So we have parameters, we have defined PDOs for that case in the newest specification, which we are going to release very soon. Two last slides, and we have still some time for discussion. If you have any further questions, you can find all details on our website, contact data, contact information, email, and so on. And that is where I say. Thank you very much for participation.